Let's look at our last example for this lesson. We have a coffee shop tracks customer preferences. Let A be the event that a customer orders a pastry. B is the event that a customer orders a specialty drink. We're given that the probability of A is 0.4 and the probability of B is 0.3. Now we're going to complete all the same problems, but we're going to do it side by side, where one case we have independent events, and in the second case, we have mutually exclusive events. So let's look at scenario 1 first. We're going to assume that A and B are independent events. If A and B are independent events, then we know that the probability of A given B is the same as the probability of A. And then we can reverse the letters and also say that the probability of B given A is also equivalent to the probability of B. And we know this because the events are independent. So for part A, it says find the probability of A and B. Our formula to find the probability of A and B is the probability of A times the probability of B given A. Now, because we know that the probability of B given A is the same as the probability of B, that's what we have up here, and that is because they're independent. I can rewrite this as the probability of A times the probability of B. When I multiply those two together, I'm going to have 0.4 times 0.3. That gives me 0.12. For part B, we're going to find the probability of A or B. The formula for A or B is our addition rule. So that's the probability of A plus the probability of B, and then we subtract the overlap. Now, we know the probability of A and B. That was given to us in the problem, and we just found the probability of A and B, so we have all the information we need. The probability of A is 0.4, the probability of B is 0.3, and the probability of A and B is 0.12, so we're going to subtract 0.12, and when we work that out, we're going to get an answer of 0.58 for the probability of A or B. For part C, we need to find the probability of B given A. Now, under other circumstances, we might have to do some work to figure that out, but because they're independent, I know that the probability of B given A is the same as the probability of B, and I know that that's equivalent to 0.3. Now let's find the probability of B and A complement, which means not A. So we can do this using our formula, the probability of B times the probability of A complement, where we use the multiplication rule. So the probability of B is 0.3. The complement of the probability of A is 1 minus the probability of A. So 1 minus 0.4. Probability of A is 40%, which is 0.4. So A complement is going to be 60%, which is 0.6. So I'm going to take 0.3 times 0.6, and we're going to get 0.18. Now, for part E, we have the probability of A complement and B complement. So we're going to take the probability of A complement times the probability of B complement. When I multiply those together, I get 0.6 times 0.7, because the probability of B is 0.3, so the complement is going to be 0.7. So when I multiply those together, my answer is going to be 0.42. Now let's look at the scenario where we're assuming that the events are mutually exclusive. So we're not assuming anymore that they're independent. We're assuming that they're mutually exclusive. And as soon as we know that they're mutually exclusive, we know that the probability of A and B is 0. If they have nothing in common, then the probability of them happening together at the same time is 0. For part B, the probability of A or B, with our addition rule, we have the probability of A or B as the probability of A plus the probability of B, and then we subtract the probability of A and B, but we know that that's 0, so we don't have to worry about it. So we're just going to take and add the probability of A, which is 0.4, to the probability of B, which is 0.3. Now, if you want, you can add it in just as a reminder that they're mutually exclusive. You can add in a -0, but you don't have to. So our final answer for part B in scenario 2 is 0.7. For part C, we're asked to find the probability of A given B. If we assume that event B has occurred, because we know that A and B cannot occur at the same time because they're mutually exclusive, we know that the probability of A, given that B has happened, is 0. Now, that's thinking through it logically. If you want to look at it in terms of the formula, remember the formula for A and B, we can write it with the letters reversed, where I have the probability of B times the probability of A given B. Because A and B are mutually exclusive, we know that the probability of A and B is 0. We know the probability of B is 0.3, and we're looking for the probability of A given B. So 0.3 times what value would give me 0? So this would have to be 0. So based on thinking about it logically and based on looking at it using the formula, in either case, we're going to get a 0. Looking at part D, I'm going to show you how you can find this probability by using a Venn diagram. Now, because we know that A and B are mutually exclusive events, they don't overlap, they have nothing in common. So circle A is going to be completely separate than circle B. I want to find the probability of A complement, meaning not A, and B happening together at the same time. So a way to visualize this, I'm going to shade in the area that's considered a complement. I'm going to do that with this light yellow color. Anything that is considered a complement outside the circle A, I'm going to shade yellow, and that is our A complement. Anything that is not A, so all of this, that includes B as well. Now I'm going to shade B a different color so we can see where it overlaps. Let's see. So I'll shade the event B in this pink color. So event B is in that pink color. Now, because we're looking for the and statement, we're looking to see where the yellow and the pink overlap. What do they have in common? That is the entire set B. So the probability of A complement and B is the same as saying what's the probability of B. That's where they overlap. And we know that the probability of B is 0.3. So that will be our final answer for part D. Let's solve E the same way. Again, we're going to draw A and B separately because they're mutually exclusive. We're trying to find the probability of A complement and B complement. I'm going to shade A complement in yellow. So A complement is everything except for A. So everything outside the circle A, which includes the set B. I'm going to shade B complement in this pinkish color. I'll use stripes or something so you can see the difference. So outside of B is B complement, anything outside of B. So we need to find where the yellow and the pink overlap. And that happens outside of A and B together. So that is all this area. I'll do it in blue. So that the place where they overlap is everything outside the circle for both of them. And this blue shaded color, the whole box represents everything. So that's 100% or 1. But we don't want set A and B. What we want is everything in the blue. So we're going to subtract off the probability of A, and we're going to subtract off the probability of B. And what's left is going to be in that blue shaded area where the yellow and the pink overlap. So we're going to take 1 minus 0.4 minus 0.3. So that's going to leave us with 0.3. So the probability of A complement and B complement is 0.3.